Question 10, I'd say actually was one of the most difficult questions that we've got here. A shouldn't have been any problem though. You know t is greater than minus 2/3, and so x is going to be greater than the ln of minus 2/3 at 2. X is greater than the ln of 4/3 was the easy mark to start you off here. You're then being asked to find out what this area is. And you should have known that this area is y times by dx by dt, a parametric integration. It's new on the syllabus this year, so we're expecting a question on it. We know what y is. Y is 1 over t plus 1. We can figure out what dx by dt is. That's what this one differentiates to give. And so that's 1 over t plus 2. We want to integrate that with respect to t. Perhaps we could figure out what the bounds were going to be as well, couldn't we? Look, if x is going to be ln 2, then t is clearly going to be 0. And if x is going to be ln 4, then t is clearly going to be 2. So we could get something like that. You haven't got many marks yet, though, and that's because you have to make an attempt at this integral before you start getting any interesting marks. And this integral is 2 fractions. So what we're really looking for is this is going to be a partial fraction question. We're going to try and split this up. This is what we're trying to do. We're going to try and split this up into a over t plus 1 plus b over t plus 2. So multiplying up here, then what we're trying to do is trying to find out when this bit here is equal to 1. So when t is equal to minus 1, you then get a equals 1. And when t is equal to minus 2, you get minus b equals 1. So b equals minus 1 here. The integral we're trying to do is the integral from 0 to 2 of 1 over t plus 1 minus 1 over t plus 2 dt. So this integral is easy now. Finally we can do it. This is the ln of t plus 1. This is the ln of t plus 2. This is between 0 and 2. Let's merge these together into one ln, because when we're taking away the ln, when we're taking away our ln's, we divide the algebra. And putting in the 2 gives me 3/4. Putting in the 0 gives me 1/2. The final line is divide again. 3/4 divided by 1/2 is 3 over 2. I mean, as it is to show that, I might even want to do another line there to show that that's the same as 6 over 4 and cancel it down. Look, that was a tough integral, and there weren't very many marks if you didn't start off in the right direction. The alternative way of doing it, of actually finding out what t is, and so going t is e to the x minus 2, and then dropping that in there, and so having to try and do the integral of 1 over e to the x minus 1. Look, great idea, but you haven't got a mark yet. You don't get a mark until you've actually started this differentiation, and you'll again have to go through some substitution to try and get to the partial fractions there. So that's really not a wise direction to go in.